Welcome to a journey where culinary art meets cutting-edge science. Today, we unravel the secrets behind the perfect pizza crust. It's a masterpiece born from heat and precision, a symphony of thermodynamic processes that transform simple ingredients. From the moment it enters the inferno, a complex dance of physics and chemistry begins, shaping its texture and flavor. Let's dive deep into the science that turns dough into that irresistible, crispy, and chewy foundation we all crave. The journey starts with the dough itself. As heat penetrates, water within the dough rapidly turns into steam. This steam, trapped by the gluten network, creates countless air pockets, giving the crust its characteristic airy structure. Simultaneously, the intense heat causes the gluten proteins to denature and coagulate, setting the dough's structure. This process is crucial for achieving that perfect balance of crispness on the outside and chewiness within. But how does this heat reach every part of our pizza so effectively? It's a combination of three fundamental heat transfer methods. First, conduction. The scorching hot pizza stone directly transfers heat to the base of the dough. This rapid transfer creates the initial crispness, preventing a soggy bottom and ensuring a firm foundation. Next, convection. Hot air circulates within the oven, enveloping the pizza and cooking it evenly from all sides. This constant flow ensures that the top of the crust and toppings receive consistent heat, promoting uniform baking. Finally, radiation. The intense infrared energy from the oven walls and flames directly toasts the crust and melts the cheese. This radiant heat is particularly responsible for the beautiful browning and blistering on the crust's surface. As the crust bakes, another magical transformation occurs: the Maillard reaction. This is where true flavor develops. Sugars and amino acids in the dough react under high heat, creating hundreds of new flavor compounds. This reaction is responsible for the rich, complex aromas and the deep savory notes of a perfectly baked crust. It's not just about browning. It's about unlocking a spectrum of deliciousness that defines great pizza. As the baking progresses, the crust continues to develop. The edges puff up, creating a beautiful cornice. These charred spots, often called leopard spotting, are a hallmark of a high-temperature bake and exceptional flavor. The cheese, meanwhile, undergoes its own transformation. Proteins denature, fats render, and moisture evaporates. This creates that irresistible gooey texture and slightly browned, caramelized patches that add depth to every bite. The perfect pizza crust is a delicate balance, a race against time where every second in the oven counts. Too little heat, and it's pale and doughy. Too much, and it's burnt and bitter. Precision is key. And then, the moment of truth, the pizza emerges. A golden brown marvel, fragrant and alive with texture. The crust crackles audibly, a symphony of crispness that promises satisfaction with every bite. A perfect slice is lifted, revealing the airy, open crumb structure within, a testament to the steam's work. The melted cheese stretches, a visual cue of its perfect consistency, clinging to the toppings. Every element, from the initial dough to the final char, plays a vital role in this culinary marvel. It's a testament to how understanding science can elevate our everyday cooking to an art form. So next time you enjoy a slice, remember the incredible journey of heat and transformation that created it. It's more than just food. It's a delicious demonstration of physics and chemistry in action, where heat becomes flavor, and science creates pure culinary magic.